Okay, I'm going to talk a little bit about the characterization of the atom. So, what we really owe, the characterization of an atom to is radiation. And so radiation is the emission and transmission, or sorry, the emission and transition of energy through space in the form of waves. Um, Now, that's a little vague, and that's okay. We don't need to go in depth about what radiation is right now, um, but it's good to realize that experiments using different types of radiation allowed us to better understand what really makes up an atom. Okay, so initially there was just Dalton's atomic theory that proposed that there were these things called atoms, okay, that make up elements, and that they're the smallest unit of an element. Um, but they wanted to better understand, really, or really understand, is that true? Do we have these smallest units, that we're going to call atoms that make up an element? And so they studied different samples using radiation. And radiation is something that was discovered by Henry Becquerel. And so he just discovered, or he did different studies that he recognized that there was this radiation coming off of things. Okay. And so then once that was discovered, they decided to try to manipulate matter with that. So use that to study matter. Okay. And so there were several experiments that were done to understand the structure of atoms and to characterize what really is an atom using radiation. And kind of what came out from this, at least relative to Dalton's atomic theory, is that even though initially when atoms were proposed by Dalton, and he said that they're indivisible, they're the smallest unit of an element, really what these experiments told us is that's not 100% true, okay? Or it's not true, I should say. It's the smallest unit kind of in the sense of when you have chemical reactions, you kind of do have these atoms that stay constant in some sense, but you do still have actual subatomic particles, so they are made up of smaller units. And in terms of, say, chemical reactions, the most important part of that is that there's electrons, and those electrons do kind of undergo changes, or they leave or come into an atom in these different changes, okay? But there's more than that. It's more than just electrons. But there's several experiments, so I should probably say a lot more than several, but there's several that are kind of important in the steps of understanding the structure of an atom. And so we'll just hit on some highlights of these key experiments and what they told us about the structure of an atom. So the first we'll look at is J.J. Thomson's experiments. And so he did cathode ray experiments. Now, I'm not going to go in depth to talk about what this is. You can read up on it if you're interested. But basically, he passed electricity through these samples, or through this cathode ray tube, and was able to knock charged particles off of these substances. And so what he found was there's some sort of negative particle that is coming off of these substances when this voltage is applied. Okay, and he was able to measure the charge to mass ratio of these particles, and he found that it's a constant ratio. So they have some sort of constant charge to them. Okay, so he didn't measure the actual charge, he measured the charge to mass. And so he didn't break it down into the individual negative particles, but he knew there were negative particles. Okay, and those negative particles are the electrons. Okay, and so from that, he proposed a model of an atom. Okay, so he proposed, well, in an atom, if there's these negative particles that we can knock off of it, that it must have these individual negative particles, but we know an atom is neutral, so it also has to have some positive charge. And so what he proposed is that you have like this positive sphere, so this kind of constant space of positive charge, or this ball of positive charge, and that within it there were these particles that have a negative charge, and those negatives could get knocked out. Okay, but the positive charge is just kind of that large sphere. Okay, and so that was called the plum pudding model. And so that was kind of the initial step in better understanding kind of what made up these atoms that Dalton proposed. Okay, and then from there, another really important experiment are the oil drop experiments that were done by Robert Millikan. And so what he did is, he would spray oil droplets into this setup and pass x-rays through them. And so basically he would get them charged, okay? And then he would apply this magnetic field, cause them to hover at a certain point, and based on that, he was able to then further study these negative particles that Thomson had discovered, okay? And so what he could do was determine the actual charge and the actual mass of these particles by doing these oil drop experiments, okay? So that information Thomson had, he could kind of pull it apart further to get more, to understand a little bit better what are these individual particles, okay? What makes up these individual particles that we're calling electrons. And then from there, another really important experiment were the gold foil experiments done by Ernest Rutherford. And so Ernest Rutherford basically took a thin gold foil made up of like one atom thick, okay, of gold, and passed, or I should say, bombarded it with alpha particles, okay? And so he shot these alpha particles, which is a type of radiation, at this gold foil, and then detected what happened to them, okay? Where'd they go from there? And so some of them went straight through, and some of them were deflected back, okay? But what was expected was that they should just pass through, okay? It wasn't expected that you would have them deflect back, because relative to this dispersed positive charge in the plum pudding model, those particles should have just been able to pass right through, because their positive charge is so much greater and they're so dense compared to what the plum pudding model suggested made up those atoms. But the deflection of a small number of those indicated that somewhere in those atoms was a very dense area of positive charge, okay, that was causing these positive alpha particles to get kicked back. Okay, these very heavy positive particles to get kicked back. And so that then kind of narrowed things down to the having a structure of, instead of this positive kind of fluid, I guess you could say, with these negative particles in it, to we must have this positive region, okay, and so this cluster of positive stuff, and then negative particles dispersed about. And so Rutherford, called this positive region where all these positive particles were the nucleus, okay? But then from there was still something missing, because there was still a large amount of mass of the atom that wasn't accounted for. And that was kind of accounted for based on experiments that James Chadwick did. So he basically discovered the existence of neutrons. And so the neutrons have that extra mass that was unaccounted for by quantifying what's there because of the electrons and the protons or that positive charge in what they called the nucleus. Okay, and The neutrons then were determined to have no charge because the protons, there would have been the same amount as electrons to make it overall neutral. So then if there was anything else additional there, it had to be neutral. So that those were the main experiments that helped kind of build our understanding of an atom, of what makes up an atom, that atom that Dalton proposed.